In the chapter of partial differentiation, we are going to have a new concept, namely, suppose if you write u is equal to f of xy, the meaning is u depends upon two variables x and y, or u is a function of x and y, means u is a function of two variables. U is a function of two variables x and y. This is the meaning. Or u depends upon two variables x and y. Now observe that if y equals fx, we have studied, if y is equal to fx, y depends upon only one variable x. Therefore, if you are asked to differentiate y with respect to x, then there is no way you have to differentiate y with respect to single variable x only. Therefore, answer is dy by dx. Now observe here, if I ask you differentiate u, then you will ask the question, should I differentiate u with respect to x, sir, or should I differentiate u with respect to y? So if I simply say differentiate u, I am wrong because u depends upon two variables x and y. Therefore, when u is equal to f of xy, always there are two questions. One question is, when you differentiate u with respect to x, what happens? Next, when you differentiate u with respect to y, what happens? So, when you differentiate u with respect to x, we get a quantity called ux. Ux means another symbol is delta u by delta x. Similarly, uy means delta u by delta y. The meaning is ux means partial derivative. We write it as partial derivative of u with respect to x. Ux means delta u by delta x, or it is partial differentiation of u with respect to x. Similarly, uy means delta u by delta y. We call it as partial derivative of u with respect to y. Now observe here, if you are asked to calculate ux, how do you do? The procedure is like this. To find ux, what you have to do? Differentiate u as usual with respect to x. Differentiate u as usual with respect to x. This is very important. Keeping any y term as constant. This is very important. If you are asked to find ux, that is partial derivative of u with respect to x, or delta over delta x, how do you do? Differentiate u as usual with respect to x, like this only. But in the mind, when you are differentiating with respect to x, in the mind, be careful. You should keep any y term as constant. Similarly here, to find uy, how do you find uy? Same way. To find uy, differentiate u with respect to y. Differentiate u with respect to y. Here, keeping any x term as constant. Keeping any x term as constant. Keeping any x term as constant. So, how do you find delta over delta x? Differentiate u with respect to x. In the mind, be careful. When you are differentiating with respect to x, you should keep any y term as constant. How do you find uy? That is delta over delta y. You differentiate u as usual with respect to y, but you must keep any x term as constant. Here ux and uy are there, they are called first order partial derivatives. What is the name? They are called first order partial derivatives. We call it as first order partial derivative. Now, when you have ux and uy, now using ux and uy, you can produce or you can find many more quantities. For example, suppose if you differentiate ux again partially with respect to x, you will get uxx or u double x. Similarly, take uy and you differentiate uy again partially with respect to y, you will get uyy or u double y. Another symbol is uxx, we write it as delta square u by delta x square. Similarly, how do you write u by y? We call it as delta square u by delta y square. So you can see here, you can write it like this also. How do you get u double x? Take u. Next, you have to find ux. Look here, ux. Ux means delta u by delta x. When you take ux, that is delta u by delta x. If you want u double x, again you differentiate ux with respect to x. That means delta by delta x. So, meaning of u double x is delta square by delta x square means take u, differentiate one time partially with respect to x, you will get delta by delta x. You want second time also, you know, therefore take delta by delta x and again differentiate it partially with respect to x. You will get delta by delta x of delta by delta x. Similarly, this notation, how do you write? U by y means delta square by delta y square. Take y. First you want uy. Uy means you find delta u by delta y. Delta u by delta y. U double y means take uy. That means take uy. And you again differentiate partially with respect to y. That means delta by delta y. Now observe here, ux is there and uy is there. You can generate one more term. When you differentiate ux with respect to y, or you take uy and differentiate partially with respect to x. Ux, when you again differentiate partially with respect to y, remember it is uxy, that's the symbol. Uy, when you differentiate again partially with respect to x, you will get u by x. Always uxy equals u by x. This is one of the most important property. Always uxy equals u by x. The meaning is, when you are given u, which is a function of two variables, whether you differentiate u partially with respect to x and then with respect to y, or when you take u, you differentiate first with respect to y and then partially with respect to x, answer is same. Uxy equals u by x means we can differentiate u either first partially with respect to x and then with respect to y, or first partially with respect to y and then partially with respect to x. The symbols, if you want to know, look here. Uxy, the meaning you should understand. Take u, therefore I will take u. And then you want ux. Ux means delta u by delta x. Next you take ux. So I take ux, that is delta by delta x. You want uxy. Uxy means differentiate ux again with respect to y. You get delta by delta y. So if you want to write this, you write it as delta by delta y of delta by delta x. That means delta square u by, in this order, delta by delta x. This symbol you should learn all of them. You can write uxy in this way or in this way. Delta by delta x. You can write it as delta by delta x. Similarly, how to write u by x? Look here, u by x. If you want to find, take u. Say take u. Next, find uy. Uy means find delta u by delta y. Take uy. So I will take uy. That is delta by delta y. Differentiate uy with respect to x. That means delta by delta x. So if you want to write it, we can write it as delta square by delta x delta y. Same order of u. So delta square u by delta x delta y. So this is one more way of writing all this. Now observe here, u double x, u double y, uxy, ux. They are there, you know, they are called second order partial derivatives. So u double x, u double y, uxy, uyx. These are there, you know, these are called second order partial derivatives. Second order partial derivatives. This is a new concept. You have studied differentiation in PUC, but this is partial differentiation. Before entering into problems, you must learn by heart, understand symbols, that is ux, uy, u double x, u double y, uxy, uy.